Hello friends, in today's tutorial we will be discussing about floating toolpath patterns using boneless 35 mm. Okay, so let us take model dimension as standard sheet sizes at 8 by 4 feet. I have taken the dimension in mm with center of the sheet as origin. Okay, I have downloaded one image in order to explain properly here. Let us discuss that image here. Firstly, this is the tool that we'll be going to use in this floating pattern. Okay, I'll be take the tool diameter as a 35 mm and its maximum cutting depth, that is here is h. H is the maximum cutting depth here, it is equal to the half of the diameter, that is half of 35 mm, that is 17.5 mm, and the shank here is 12 mm, that is not a big matter. Okay, so this is the tool that we'll be going to use in this floating pattern. Okay, so you can see the nomenclature how they have made is ball nose 35 mm, 17 is the maximum cutting length. Okay, you can use it for 18 mm sheet and also for 25 mm sheet. You can choose the variable cutting depth as per the tools parameters. So let us discuss. Firstly, this glare I don't want, so let us make this default modeling shade. Okay, so now you can see we have made this standard glare. Now let us draw the tool firstly. Let's make a 35 mm circle, 35 mm diameter circle, sorry 35. Okay, apply, press F9, it will go to the center. Now insert a horizontal guideline, that is Y guideline, make it tangent to the circle. Now insert a guideline with 17.5 mm relative to it. You can see it will go from the center of the circle, and now you can insert another line here. Okay, now cut it. This is the tools profile. Now make the shank as a 12 mm. So this is how our tool is. Okay, so for 17 mm, let us consider a practical case that we are going to float it for 18 mm thick 8 by 4 feet sheet, that is standard size 1.22 meter by 2.44 meter, 18 mm thickness. Okay, what is the here the maximum cutting limit is 17.5, but we can't do that much. We will limit it to up to 10 mm only. Okay, let us do it for 10 mm only cutting depth. Maximum I want is 10 mm. 8 mm will be the best for it. Okay, so let us take the relative offset to the same tangent as a 10 mm. You will get the cutting depth for 10, sorry, the cutting width for cutting depth of 10 mm. Okay, that is up to 31.6 mm. Okay, 31.6 mm. So what I will be doing here is I will make one line vertical with a complete length of 2.44 meter. Okay, can take here as 2440 mm. Okay. Now press F9, let it be the center. Since we have decided to do 10 mm maximum depth, okay, so it is giving the maximum cutting width as 31.6. We will consider 30 mm. Okay, okay, let us take, select this line and choose the block and copy. Take the gap as 31.66. You can take, but I am taking round of values just to show you. 30 mm and the 20 to 40 columns. Okay, see the rails for the floating has been made now. Okay, now insert another horizontal line here and again make a relative offset of 12 mm, sorry 10 mm. That is our cutting depth for 31.6 cutting width. That is just now I have explained here with this tool. Okay, make one horizontal. See, now we are making a jet modulation curve, or you can call it as a fluting curve, tool traverse path. Okay, I have drawn one arc with a 10 mm and mirror it to the right hand top. Okay, now join them. This is a complete wavelength. See the green point repeated after a particular travel path, that is called as wavelength. Okay, so let us keep its sizes as 122 and height as 10 mm. Apply. Okay, and also make it align with this guideline. Okay, now use the same thing, block and copy, but this time take it 20 columns and one row with the gap of 0. Okay, see, now you can see this. I'm also making one relative offset guideline for the vertical. Okay, this is our total 2.44 mm length. Okay, so let us choose the 2D toolpath here as the floating. See, in order to make the floating pattern on this rows, railings, you should need the floating vector with the starting and end start point and the end point should be on the topmost surface line. Okay, see, if I choose, see, in this you should choose the Z control vector. You can call it as Z control vector, Z modulation curve, or floating vector, or tool traverse path. Okay, Okay. Take the finish depth here as a 10 mm. Okay. Then choose the fluting tool. I have already created it. You can see the dimensions and all. Step down, you can keep it as 17.5 mm. Okay. Okay. Select. Now choose this. Now you will get the option as selected. Okay. This is the Z modulation curve that we have got selected here. It will let us see if it calculates properly. Define the material as 18 mm and simply calculate. See, I have told that start and end point must be on at the top of the bounding box. Okay, so let us do that condition here. Go into the node edit mode. Firstly, close this. Go into the node edit mode by pressing L, or you can directly click here, node editing, and then insert I press I to insert node in this topmost bounding box. Then the remaining cutting part, you should press Alt and simply drag it to the end of this Z modulation curve and simply join it with this vector. Okay, so now you can see the starting green point and the red point, which is the end point, is on the same top bounding box. The message that we have got, now we have satisfied that condition. Now let us reverse this vector, or you can keep it as the same way and just simply recalculate this floating toolpath. Okay. Okay, so now we have to select this Z modulation, Z control vector again, and simply select this and recalculate. Go into the isometric view. You can see this neck type, wave type pattern of the shade control vector in this red toolpath tool vector. Let us simulate it. Now you can see how the tool is going. Oh, sorry, slow. Now you can see ups and downs. Okay, directly to the final simulation, or you can directly press here, simulate all toolpath. That's it. This is the final view. See, it has got intersected. Okay, now you can choose the random, or you can simply shift your jet modulation with complete one amplitude or a wavelength, will complete one wavelength size. Firstly, delete this simulation. Choose alternate vectors. Hold shift key and press alternate vectors. After selecting all the alternate vectors, just simply group them, then select all these rails and deselect by pressing shift key, and again group the remaining vectors. Okay, so now what we will be doing here is we will shift the pattern, alternate pattern equal to wavelength size, that is 122 mm. Okay, so in order to do that, firstly insert a horizontal guideline. Okay, and then right click on it and simply choose a relative offset and take -122 and insert it. One of the alternate group vectors, you should press Alt and move all of them, shift them with 122 downwards. Okay, so let us calculate the fluting for this topmost layer. I will call it as a topmost, and this one is downmost. Top railings with 10 mm finish depth calculated. Okay, now again choose another 2D toolpath, floating toolpath, but this time you have to calculate it with downward railing groups. Okay, the cutting depth as 10 mm. Choose the same fluting tool as 35 mm, where it is here. Okay, and again select this Z modulation here. Okay, it has got selected. Now choose the downward railing vector group and again calculate. Now you can see another fluting layer toolpath has been added here in the project menu. Now simply simulate both these toolpaths. Now you can see this pattern. Something wrong. Let us figure it. Okay, delete the simulation. Sorry, I haven't chosen the finished name. I have chosen it. Everything is correct here also. I think I have taken the wavelength as 122 value, that is incorrect here because the same point comes here also. So it is my calculation mistake. You should take the displacement as half of 122, that is 61 you can take. Okay, so this downward railing should come here. So let us directly calculate it. Now we know our mistakes. Now calculate it. Let us see how it is looking. See, now we have got a similar pattern. Okay, okay, okay. So let us play with this pattern in order to get this type of this yellow type of, in order to get this yellow type of this yellow wave pattern in this image, let us play with this parameter of this toolpaths. Okay, let us take the starting depth as 2 mm, or you can take it as 3 mm also. Start calculating. Then for the second one also, take the starting depth as 3 mm. Now, since we have given a 3 mm advance starting depth, let us see how it is going to look now. Firstly, reset it and then simulate all toolpath. Now you can see similar type of pattern as that of image. Okay, if you want to remove this flat surface, you can increase this starting depth, and also this finish depth also in the same proportion, so that you can get this flat surface off from this pattern. Okay, you can play with it. You can try 3 different groups and give 3 different fluting patterns. You can try with, since we have tried here half of the wavelength, that is 122 ka half, that is 61. You can try with 30.5 and one with 61 and another with uh, 1/4 of 30, that is you can try with 15, 30 and 60. Okay, for 122 wavelength. Okay, so let us see if we give the fringe depth as a 12 mm, and let us see what is the output. Sorry, make the visible all this toolpath. Let us see if we give 12 mm with the starting depth as a 3 only. Okay, I have given only one with 3. Okay, so let us see the simulation now. You can try also, you can make many n number of possibilities are there. You can do the variation in cutting depths. Okay, you can do the variation using this layer shifting. You can do the variation using uh, tools cutting depth, then distance between the railings. Okay, and just by simply shifting the vector groups, as well as you can also change the fluting pattern. Any alternating pattern you can take, or combination of alternative patterns with alternative, that is a part of permutation and combination. You can make n number of fluting pattern, but I can't show in this tutorial all these those pattern. I will simply show some basic things so you can think and make many number of patterns and simply save those toolpath and load into your CNC and get the fluting done. Okay, so let us see how it is looking now. Since we have chosen one as a 50 and one of it is in the same previous parameter. Okay, so one is going 15 mm depth, sorry, 3 plus 12, and one is going 3 with 10. So let us do this also 15 and this also. Let us take it as 12 only. Let us see what it gives now. Toolpath simulation, simulate all that. Okay, this 3 with 15 and 3 with 12. See, now you can see this is another pattern. You can, one more option is there, you can keep both same. This also you should take 15 so that this flat surface that is coming here should get vanish, intersects. Okay, toolpath simulation, simulate. Okay, see, this has got reduced. Okay, if this taking more than the width of the sheet, you can simply compress this group of vectors. Let me show you that also. Firstly, delete this simulation, but in that if we reduce this uh, width of this grouped railings vectors, like now it is on the 1170. Let us take half of it, that is 585. I already made the calculation. Let's take 590. Okay, do not scale it, do not do not log this aspect ratio, simply compress it, compress the width. Okay, recalculate both. Let us see what it comes. Everything you can try in this ArtCam with trial and error by the visual means. You just need to simulate and predict what the detail and simply load it to the CNC machine. Let us calculate it. It will be definitely going to intersect because we have decreased this width of these groups, so it has to, but let us see how it is coming. Just recalculating now. So here we go with the simulations. See, it is intersected more than necessary. Okay, this is another pattern which we have got now. Now let us not give it the static depth, make it with 5 mm, or you can take 7, calculate. Okay, also this one 0 and 7. Since we have reduced it, so we also need to reduce the finish depth. Okay, now let us see the result. See, now it is looking same as per that image. Only thing is you need to reduce some patterns or some parameters that I have to do the variations. Okay, I hope you have got the idea. Now, in order to save the toolpath, just simply click here. Whatever the processor you have, simply choose that. I use Camtech RMS and simply save the toolpath. Save both toolpath in the same toolpath. Okay, save toolpath. Okay, save toolpath to same file and simply press the save. Okay, I hope you have liked this video. Please like, comment, subscribe and share. Whatever you need, any doubt you can comment. Also you can comment with the new ideas and also any requirement or inquiry you want to do or ask with me. You can contact me on my WhatsApp number. It is there on this description of video. Thank you so much.